Alright, let's get started with our third hazard analysis. This is going to be a near-infrared YAG laser, which we see a lot of these particular lasers in systems from scribers to markers to etchers, all sorts of applications for ND YAGs. This is going to be a continuous wave YAG laser. Let's start by going to our PDB, selecting the third hazard analysis by highlighting the record, add-ins, EasyHas PDB menu, load parameters from PDB record, and we have the parameters in. 1064, continuous wave, average power 100 watts, ANSI default once again, 10 seconds. Here's our beam information in the 1 over E squared points, circular Gaussian. Major axis diameter is 5. Since it's circular, the minor axis diameter will match that. The divergence is 2 milliradians, and observer range is 0. Let's take a quick look at all of this. First thing that catches my eye is that there's a slight difference in OD value. Where do I want to go first? I want to go to transmission in the limiting aperture, and I see that it's only 98%. What this tells me is that a 5 millimeter diameter beam does not fit cleanly through a 7 millimeter aperture. Gaussian shape has wings on it. A little bit of that power gets cut off. Right? So it's only passing 98% of the beam. The average irradiance in the limiting aperture for a 100 watt YAG is 255 watts per square centimeter. The MPE is 5 milliwatts per square centimeter, hence we have a pretty large OD value. Notice that this is about twice the MPE as for a visible laser at 2.55 milliwatts per square centimeter. So what this tells us is as we move from visible into the near IR, the MPE is increasing so that longer wavelengths aren't quite as hazardous. Okay. But we'll see in the table where it's not a linear curve at all. And we'll take a look at that when we take a look at tables. We have an NOHD of a little over 1100 meters. We have a point source NHC of what we had with the CO2 laser of 0.8 meters, but notice it's only 100 watts here, and that's again because the MPE for a YAG is much lower than for a CO2. Remember, for the CO2 it was 0.1 watts per square centimeter or 100 milliwatts. This is 20 times more conservative for a YAG wavelength. Right. So this is a typical hazard analysis for an industrial YAG. We notice that for an observer, the OD is 4.7, or worst case is 4.7. We would round to OD 5. Quick check, let's put 1128 into the observer range, and our OD does go to 0. Let's put 1100. And we do have a slight OD, so this all makes sense. Looks like everything is tracking well. Last thing I want to look at is time skin MPE. The skin MPE is quite different than, let me put this back to 0 quickly. The skin MPE is different than the ocular MPE, quite a bit difference. 1 watt per square centimeter as compared to 5 milliwatts. But you're still at about 1,000 times the skin MPE. So this laser, 100 watt YAG, is a serious skin hazard. Let's look at the skin NOHD. Notice that it's only 79 meters, and that's because the MPE is greatly increased. The skin MPE is greatly increased over the ocular MPE. So we would expect the nominal skin hazard distance to be less than the nominal ocular hazard distance, and it is. Okay? So that's our third hazard analysis, and we'll leave this one alone and get ready for hazard analysis number 4.